Hello friends, we'll be taking up mensuration now. For this session we'll be talking about 2D shapes. So let's first understand what is mensuration all about. It is the branch of mathematics which deals with the study of different geometric shapes, their area, volume and related concepts. Broadly speaking, this deals with various measurements related to different shapes. Now it covers both 2D and 3D geometric shapes. So friends, let's first try to understand what is the use of finding the perimeter and area. So perimeter and area calculations are commonly used in our day-to-day life. Let's see how they're used. Perimeter is used for finding the length and cost of the fence required, finding distance that a person would walk based on the shape of the walking track, etc. Say for example you have a park or you have a specified area in the park which you want to beautify by doing something on its boundary, which could be a fence or something else, that is where you will need to find out the perimeter as to how much is the length, and then that will help in finding out the cost of doing that fencing. And similarly, if there's a park and you take a walk in that park, so if you know the perimeter, if you can find out the perimeter of the park, you'll be able to find out how many rounds of that park you need to walk to be able to complete your planned distance. Say you plan to walk 1 kilometer, 2 kilometers, you based on the perimeter you'll be able to decide how many rounds do you want to take. So these are some of the basic things where the day-to-day operations, day-to-day usage of perimeter. Again, area is also very useful when we want to find out the cost of, say, carpeting or tiling the floor, because when you want to carpet a room or you want to tile floor tiles you want to place in the room, you need to find out how many tiles or how big the carpet you need, and that is what is provided to you by finding the area of the room. So that is where you need it. And again, if you want to cultivate a farm, you want to find out what is the area of the farm and what will be the cost involved. That can be found based on finding the area of a particular shape. Again, if you have a farm and you decide that okay, only a part of it you want to cultivate, so there is a change in the work that you have done, the amount of work has reduced. So you want to calculate that, the change in the work, and hence the costing. That can be done again by finding out the areas, and again in some cases the perimeters. So these are some of the examples where we use these things in our day-to-day life. Let's now first of all do a recap of perimeter and area of basic shapes which have been done in the earlier classes. So if we take a rectangle, we know that its perimeter is given by twice of the sum of length and breadth, and its area is given as the product of length and its breadth. Now we take square. So for square, the perimeter is 4 times the side of the square, and its area is the square of the side of the square. Then we come to parallelogram. Parallelogram perimeter is twice of the sum of length and breadth. It is same as rectangle, whereas its area is base, the breadth into the height. It is not, just note the difference between the area of the rectangle where it is just the product of the length and breadth, whereas for parallelogram it is the base into height, or you could say the breadth into the height in that direction with the breadth as the base. Then we come to the circle. We know that the perimeter of the circle is given by 2 pi multiplied by the radius of the circle, and its area is given by pi r square. Now we come to the triangle. For triangle, the perimeter is just the sum of the three sides of the triangle, whereas its area is half into base into the height. So now let's talk about some more formulas related to the area of triangle. Let's first take an equilateral triangle with a side A. So now first thing to note here is that the formulas for area of a triangle that we're talking now, they are in addition to the basic formula that we've studied in earlier classes, which is half into base into height. So if we take an equilateral triangle with the side A, the area is given by root 3 by 4 into A square. So we can also see how we come to this. If we draw a perpendicular from this vertex, say we call it capital A, if we draw a perpendicular from this vertex to the base, then this is the height of the triangle, and if we use the Pythagoras theorem, we say that h square is equal to the hypotenuse of this right angle triangle, which is A, square of this minus this side, which is A by 2, square of this. So we have A square by 4. So we say h square becomes equal to 3 by 4 A square, or we can say h is equal to root 3 by 2 A. And since the basic formula that we've read for the area of a triangle is given by half into the base, which in this case is A, into the height, which we've just derived is root 3 by 2A. So multiplying these three, we get the area of an equilateral triangle to be equal to root 3 by 4 A square. Now let's look at the Heron's formula for finding the area of a triangle. This formula is applicable for all types of triangle. So if we say take a triangle with the sides A, B and C, the Heron's formula says that the area of the triangle, such a triangle, is given by S into S minus A into S minus B into S minus C whole square root. Now what is S here? S is the semi-perimeter of this triangle, which means it is equal to A plus B plus C divided by 2, because the perimeter of the triangle is A plus B plus C, and perimeter S will become A plus B plus C by 2. So again, the Heron's formula states that area of a triangle is given by the formula S into S minus A into S minus B into S minus C whole square root. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.